And here we are in the lab again, and this is episode 1 of a new video series. And this video series is about MainBrain. So MainBrain is a small microcontroller that I have built for my own use and my own learning, and I want to share it with you guys. And put it on upside right here so you can see the logo. Sometimes I refer to it sometimes as MainBrain 32 because this is a version of MainBrain where the microprocessor is a 32-bit microchip microcontroller. So I call it MainBrain 32 because the original one, I still have one here and it still works. This is the first design where I was figuring stuff out. And this one actually has an Ethernet port. And the connector was down here on the side originally, and we improved upon that by doing a smaller, more compact connector on the end. Let's see here, like this. It's right here. And the ribbon cable plugs in. So that, and that's the interface to the outside world. So the idea is that you take another board. This just happens to be a motion board that I developed. And this is the first one. And then we also have a newly developed board here. You can see a jumper wire on it right here. So there's going to be another revision. But this is just an I/O board that we did a video series on previously. All right, so these guys go on the bottom of MainBrain like this. Okay, it's like a sandwich or a stack. And then on here, a ribbon cable connects it together. I don't know where my ribbon, oh, here it is. So this ribbon cable connects them together right here. So the ribbon cable goes on like that, and it allows you, you can like fold it out, and then you have access to the chip so that you can troubleshoot it. Or you can do it a normal operation. It sandwiches together like this. And then you can put another board. You can put another connector on the ribbon cable, and then you can add another board on the bottom like this. So you can have up to 7 boards on here. All right. So that's MainBrain. Now, it has a touch display, capacitive touch. I worked with resistive touch. It doesn't work as good. The capacitive touch works a lot better. So that's pretty much what MainBrain is. And then we're going to get into the different parts of it and how to build it, program it, and use it. So that's what this video series is about right now. All right. So the first part is going to be a little bit more introduction, and then we're going to talk about the microcontroller, which is a microchip PIC32. And we're going to start out by programming that, getting it started up, minimum requirements, all that stuff, the internals. We're going to study the microcontroller pretty heavily. And then we'll go into how the board works, because we have a dual port SRAM that interfaces through the connector. And we have a little bit of flash memory here. And then, of course, we have our ICSP connector to program the microcontroller. We have a little buzzer here, so we can beep. We can even probably play some sounds. And then we have its onboard power supply. It has an onboard 3-amp switching supply. So, and it powers MainBrain and the other boards if necessary. But some of the boards, like the motion board, gets its 3.3 volts for the microcontroller right here. But since it's a motion board and the motor runs on 24 volts, so it has to have an external supply for the motor. But so some boards will have external supplies, but all the board, the 3.3 volt logic, comes from MainBrain's power supply. And so, okay, MainBrain, the power supply, has a connector right here that can take in from 24 volts to down to about, I don't know, 7, maybe 5. We'll do some testing on that. This is in its final stages of development, where we have one more revision, and that should clean up all the problems, because this flash memory chip right here, the package got discontinued. So I have to issue a revision with it's a little, the same kind of package, just a little bigger. So I have to enter, or I have to do a revision on that just to clean that up. But I'm going to do, the power supply can be it's a little bit noisy kind of. So I want to clean that up a little bit. And that's pretty much it for MainBrain. It's been running for a while. It doesn't have a Ethernet port anymore, although we might build an Ethernet board to go on it, but it uses USB. So we have a USB connector that connects to the PC, and then we have a Windows app to control the board. So you can control the board through the screen, or you could like not put the screen on and just control it through the Windows app. So either way, or both, however you want to do it. And there is a set of LEDs. You can see right here, 8 LEDs for status and debugging port, which helps a lot when you're writing code and trying to make something work. And that's pretty much it. Next, let's take a look at how I have MainBrain put together right here, because it makes it a little tricky with the display, to where you have to like fix the display so it doesn't plop around and damage itself. So this is what I came up with, and basically it's a piece of fiberglass circuit board material, and then I have a mill, so I milled a piece to fit this part right here. We are going to get rid of that because the LEDs are right under there, and you want to be able to see the LEDs, and this doesn't stiffen it enough to really matter. Right here, this one's standoff is missing because it's stripped out. We got to make a new one out of the machine shop. All right, so it takes these screws. I always use stainless screws, metric 3mm metric screws, and these ones are flathead for recessed holes, and it takes a 2mm hex wrench to get it apart. So we just take these screws out right here like this. If I can get them out with my gloves on here. And then we will come over here and get these off. On this end, the screen overlaps the screws a little bit, so it's harder to get them out. And now it has another standoff on the bottom that you can use for feet, or you mount another board onto it. Just made out of aluminum. I have some stainless. Maybe we'll make some stainless. All right. And then this display just lifts off. And this is where it gets tricky, because let's get these out of here. And these are the standoffs between the main board and the display. just some aluminum unthreaded. All right, so let's take this. So now if we look at it, the screen is actually glued with silicone to this board. Now, if you can see in there, it has two flexible cables. All right. So we want to take and release them. And you just lift up on the little connector very carefully because they will break. If I can get this in here where you can see it. Nice, like that. Then that pulls out. Then we got this one down here, the main display connector cable. You just lift up on that very carefully, and it pulls out. And that's the underneath the display. But the next revision, the revision that we're going to actually test in this video series, this is the CPU here. And it made it easier to lay out, but I decided to change that. And we're going to move it on to this side so that all the parts are on the same side of the board. And you can have access to every pin and every trace, well, every pin, and the display won't cover it. And you can keep the display on because it's really a pain in the butt when you want to measure pins on the CPU and you got the display sitting here and you have to lift it off, and it would be very easily to damage it. And the display's like $50, and that's not something that you want to destroy, but I have pretty much destroyed all my displays in some way. Not destroyed, but they get scratched. I don't know if you can see the scratch, but I laid it face down thinking it was okay, and it wasn't. I've touched it with the soldering iron before. My old one has a big white stain on it from sodium hydroxide got on it. I don't think I have a display right now that doesn't have a mark on it. And I keep the protective clear cover on it as long as I can too. But with the testing and moving and different things, they get scuffed. So that's something you want to consider because they are kind of pricey. But they are tough. I've ran these displays on continuously for a couple years before they start showing any kind of fading at all, and it's very minimal. You only notice it when you put it next to a new one. So the display is very robust, no problem with that. And these connectors, they only say you can only engage them and disengage them a few times, but I've done it like close to 100 times probably before on one single connector. But you have to watch, if you get too much flux on it when you solder, then it will not make a good connection, and it can cause you some problems trying to troubleshoot that. And then this little one over here is for the capacitive touch part of the screen. All right. Then here's our 8 LEDs for diagnostics. And that's pretty much the major stuff there. Like I said, we're going to move the CPU right here on the next revision, and those boards should be coming in next week. So that's the way MainBrain goes together. All right, so you've seen how MainBrain is put together. It's pretty simple. There's nothing out of the ordinary about it. The only tricky part is those connectors, and they will break. But if you get it pushed in there just right, the way it's supposed to be, and you push those connectors down, that locks on, it works great. I haven't had any problem with it as long as I put them in right. But in the early days, trying to figure out what was going on, I broke a couple. And it's usually when you push the door down, the little latch has little pins out like this that it rotates on. And it will, if you put too much force when it's not lined up in there, it pushes it up, breaks off one of those little tabs, and then it won't lock anymore. So you either have to like steal one off of another connector or replace the connector, and that's a pain in the butt either way. So you want to be careful, but once you get the hang of it, it's really easy. All right, so we took MainBrain apart in the beginning, so let's put it back together and you can see more about those connectors. All right, so the first thing we need to do is to get the display plugged back in. That's probably one of the most challenging things, especially from the first time that you do it. All right, I wish I would have used something different to put it on than this paper towel. It seems to be sliding. All right, so you want to get this out like this. These kind of have to go together, and they have to go in all the way. So let's see if we can get this in. It's going to be hard for me to show you, but see, it's got to go in, and see the line. You can see where the line is, and it's well past inside the white plastic connector. So you have the latch open when you stick it in, and then you close it down, and that locks it. So that should be good. Then we have to put this guy in here. And sometimes you can use tweezers, but if you get it lined up, it goes right in. And see, the line is at least even with the plastic body. All right, latch is open, and you just push down. Now, if it doesn't push down easily, be careful, because they will break. All right, so now that we have it like that, let's hold it before we put it together, and don't let anything inside touch. And we'll just plug it in real fast and see if it works. And it does. Okay, so we got it hooked up right. All right, so now we can just set it down, and we can put in the spacers. So you want to do this side first, because this is the overlap part here. All right, so you want to get some screws in there right here, and they just kind of go in a little bit sideways, just like that, because the display hangs over the top a little bit. All right, so those are kind of a little bit trickier. All right, so then you just take the little spacers and you get them in like that, and get another one in on this one like this. Okay, so there's that. Then you take one of these guys and you just thread it on the end right here. Get it started. Whoops. And this one looks like might be a little strip too. Let's turn it over. That's the way we need it. Just like that. Okay. One more. Just like that. All right. And then we got this guy here. One more in here like that. There we go. And there we go. And then you'd repeat for the same thing for that missing one, and then you can just snug them down with the hex key wrench. Just like that. All right. And we'll plug it in, make sure it works. And there it is. And when MainBrain boots up, it just goes into the logo. I call it the splash screen. Okay, so we got it back together and it's working. So then let's take a little deeper dive into it and let's check out the modules or the different sections of MainBrain. Let's take a look at the different modules of MainBrain, the different parts. There's 10 sections or parts or modules to MainBrain. The first one being the power supply. And next is the ICSP connector. Then we have the reset circuit module. Then next is the SRAM, the dual port SRAM. Then we have the IO connector, where the ribbon cable plugs in, where it interfaces with the outside world. Then we have the flash memory, where we store user programs and other configuration data. And then we have the CPU module, which includes the USB and 2 oscillators. One is the main oscillator, and the other one is the real-time clock oscillator. And then we have the buzzer circuit. And then we will go to the back of the board, the bottom side, and we have the display interface connectors. And then finally, we have the LED port, where we display status and debug information. Okay, so that's the basic layout of MainBrain. And so it's fairly simple. It's fairly straightforward, but there's some, once you get down into the details, it gets kind of a little more in depth. It's, I think probably the hardest part about building MainBrain is probably soldering the parts on the board. So there's at least one, the connector, and I like to do also the little oscillator chips, because that ground pad is a, you know what, it sucks a lot of heat. So it's hard to solder it with the soldering iron and get a connection. So I like to do the 2 oscillators and the IO connector in the oven. But if you don't have an oven, you can use a hot air gun tool. And you have pretty much, if you're going to work with surface mount, you pretty much have to have one or both. Because you're going to have to take chips off the board, and you can use just a regular hot air gun, but they have one specifically for soldering the small chips, so you don't just cream out the whole area around it like a nuclear bomb, because it will too. You get that heat going out once it hits the board and the part and it goes out like that. It will heat up and reflow all kinds of stuff around it. And if you got board parts on the bottom, they'll fall off many times. Depends on how they put them on. Sometimes they will put them on with a little dab of silicone. That's up to you, so that it sticks the parts on the board, and then when you flip it over and they get reflowed in the oven, they don't fall off. But so you have to be careful. So that's kind of the hard part, is getting the parts on the board. But if you have a good soldering iron with a real fine tip, and you have a little bit of experience soldering, you don't have to be a professional, and you have a little oven or hot air tool, you don't have any problem. Just attention to detail, and make sure you don't have solder shorts or unsoldered pins, and it works great. And I'll show you, we'll go step by step through every single part as we put them on the board and test different modules. Because we don't just assemble the whole board. I mean, you can, but then when you have a problem, you got to troubleshoot it. But if you just go one module at a time, and like we'll do the power supply first, make sure we have proper power, because you don't want to put all your chips on the board, plug it in, and then blow all the parts. I have done that. I have had a power supply error where it sent the 12 or 24 volts through the power supply and right out the other end. And it just instantly cooked everything. And CPU, SRAM, flash, Probably other stuff. I didn't even care to look. It just went in the garbage because and those parts, some of those parts like the SRAM, that's like $45. So that was a bad mistake. So you want to get the power supply going. You want to test it. Maybe we'll load test it. We check for the noise and see what's going on. We're going to go through it, and then we can start putting like the processor probably next, and then because all the processor needs is power and connection to an ICSP. And even though the data sheet says you got to have the caps, the bypass caps around it, if you got a clean power supply, you don't need them. You just plug that puppy right into the ICSP and you're ready to program. So uh, we'll put that on there, and then the USB is just a direct connect. There's no hocus pocus in between the CPU and the USB. It's just direct, so you can plug the USB in and test that right away, and then you can start doing some other stuff after that. And we'll do that. We'll go through the whole thing. So the next thing is probably, let's just take a look at the Windows app. Some of you have seen it before in the I/O board video, and some of you haven't. So let's just check it out and get a little familiarity with it. And so now that we're powered up, then we can plug in the USB connector right here, just like this. Okay. All right, so we will open up our Windows app here. And if you've watched one of the other videos, like the I/O board, you'll be familiar with this. So you can have multiple MainBrains connected through different USBs, and it will list the different ones. And you select which one you want by pressing the zeros. It'll ask you. And but since we only have one, you just press any key and it connects. So the first thing it does, it displays the board power. So this is the input voltage to MainBrain. So we're running on a 12-volt power supply right now. And this is how many milliamps it is consuming. All right. So it's usually a little bit lower. That's something we're going to have to look at. I think I have, there's either an I/O that's in conflict, or the SRAM is enabled all the time because MainBrain is accessing it or something. Because normally when the SRAM is not selected, it powers down. It doesn't consume, just like in the microamps. So there's something going on there we got to check out. But we're gonna develop. This is a utility that I've developed, but we're gonna together develop an application more geared at consumer application type thing. This is just utilities for testing. So for instance, you can test your connection to make sure MainBrain is connected and communicating with the app here. So you just double click that, and there you go. That means it sent a byte over to MainBrain, and MainBrain sent the right byte back and confirmed it. So, and then you can write to the LED port, or you can reset the device. If you have a motion board installed, you can build motion. You can do a COM check with any boards that you have installed, and some flash utilities, SRAM utility, and some peripheral commands and stuff you can do. So we'll get into that later. But so this, you can control MainBrain with this app through the USB, and that's the main point, is to make it easier, because you can do it through menu systems on MainBrain, or you can use this. All right. Okay, so that's pretty much MainBrain. And at this point, you might be saying, well, what can you do with it? And so I have to say, anything you want. You can do almost anything with it. It's only limited by your imagination, because if you add no other boards to MainBrain, then you can learn to program microcontrollers. You can learn how to program USB, and you can learn how to program the screen and display graphics. It has very good graphics. It can do 18-bit. Normally in my program, I do 16-bit video or graphics. Uh, but you can do 18 by bit banging the upper 2 bits. But you can do, that in itself, you can keep yourself busy learning for a long time. I mean, I've been working on this thing for years and I'm still learning stuff about it. Oh, and the touch screen, you can learn how to program the touch screen too, because it is I believe it's SPI bus, I think that you have to use, or it's I2C. I can't remember which one it is offhand, but you learn how to program that. It's a serial bus that uh, when you touch the screen, it sends a command, and in my case, I used an interrupt feature so that when you touch the screen, it sends MainBrain an interrupt, and then we process that. And it can do 2 or more touches on the screen, just like your cell phone, more or less. Not quite as good as your cell phone, but it's pretty good. And so that alone is a valuable item to have. And you feel good about you built your own controller and from scratch. And so then with the add-on boards, you can go even farther. You can I have 2 boards right now with like the IO board in the other video series that we output some old-fashioned NTSC video onto a little TV. We can measure. It outputs a PWM signal. It can switch the loads on and off, and it has different ranges that it can measure, and you can do a lot of programming with it. And then we have the motion board. I don't know where I put that. Oh, here it is. We have the motion board that I showed you earlier, and that controls a motor. And I have a setup here to test it, and we're going to go through that too. That's part of the thing. But you can build a robot. That's my intent when I started this project, was to build a robot, and I haven't made a lot of progress on the robot part, but I'm almost done with MainBrain. This is the final revision, and then we're going to move on to some bigger stuff. But MainBrain isn't really complicated, but it can do a lot of complicated things. And like I said, it's only limited by your imagination. So let's check out MainBrain down deeper in the next video and learn even more about it. And we're going to learn more on how to program various pieces of hardware, which is normally considered device driver programming. And that's one of my favorite things, but it can be hard. It'll make you cry. It can be hard. So we're going to go through all that stuff, and that's pretty much it for this video. And I will see you in video number 2.